This is part 2 of adding and subtracting fraction. Let's look at our number routine. Lonnie bought a rope that is 3 2/5 feet long. On Monday, he cut off a piece that is half a foot long. On Tuesday, he cut off a piece that is 3/10 feet long. How much rope did he have left? So let's think. There's two ways to solve this. You can start with the original quantity of 3 2/5 feet and cut off half a feet from that. And then whatever answer you get, you cut off another 3/10 feet from that. Or you can combine and figure out how much did he cut off in all. To combine the Monday and Tuesday and then take it off from the original quantity of 3 2/5. I prefer this latter way, so let me show you. So we're starting with 3 2/5 feet. We're going to combine Monday and Tuesday, 1/2 and 3/10. And then once we find the total amount that he cut off for Monday and Tuesday, we're going to take it away from the original amount. So what common denominator do these three fractions share in common? They all share tenths. So is there a way I can rename 2/5? 1/2 and 3/10. What denominator do they all share in common? I believe, if I'm not mistaken, tenths. 1/5 is equivalent to 4/10. 1/2 is equivalent to 5/10. And 3/10 is just 3/10. So let's start renaming them. So let me erase this. I'm going to use a different pen color. 3 2/5 could be renamed as 4/10. Again, I multiplied the numerator and denominator by 2. 1/2 can be renamed as 5/10. Multiply the numerator and denominator by 5. 3/10 is 3/10. So on Monday and Tuesday, 5/10 plus 3/10 is 8/10. Monday, Tuesday, he will cut off 8/10, a combined length of 8/10 from 3 and 4/10. Now this is where it gets a little more trickier. Can you take away 8/10 from 4/10? No, you cannot. What do you remember about regrouping? I regroup, 3 becomes a 2. So I started with 3 whole, now it's 2 whole. I took away 1 whole from that. Let's show you through this model. So this is 8/10. This is what he will cut off. So 1 and 3/10. Can I rename 1 whole as a fraction? I believe I can. How am I going to rename 1/10 as a fraction? 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. I'm going to rename this 1 whole as 10/10. What do you get when you combine the 4/10, these 4/10 right here, with this 10/10? It's 14/10. Now can I take away 8/10 from it? Yes, I can. Cut off, 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 cut off. I am left with 6/10. So 4/10 plus 10/10 is 14/10. Can I take away 8/10 from 14/10? Yes, I can. 2 and 6/10, which is equal to 2 and 3/5. I renamed 6/10 to 3/5. And that is our answer, 2 and 3/5. So again, what we did, we practiced on regrouping. What we did is we regroup from the whole number, if it's 1 whole, can you rename that whole number into a fraction form? And then you combine it with the numerator, 14/10. Now can you take away? You can. So I'm going to show you 5 trials. You're going to tell me if you believe if the final answer is positive and negative and why. If I combine -7 with 9, will it be positive or negative? I predict positive. How do you know? I could draw 7 negatives and 9 positives. Using 0 pairs, I have more positives by 2. Or I could start at 0 and go 7 units to the left, and then 9 units to the right, and it stops at 2. -1 plus -9. What do you predict? Positive or negative? Negative. -1 combined with -9 is -10. No 0 pairs. Or I start at 0, I go 1 left, 1 unit to the left, 9 units to the left, stop at -10. Number trial 3. 8 take away -9. So I start at 0, I'm at 8. I need to take away -9. So what does that mean? So if I start with 8, can I take away -9 from this without changing the value of 8? No, I cannot. So I need to draw 0 pairs. I need 9 0 pairs. So now, can I take away -9? Yes, I can. What two numbers are left? 8 and 9, which is 17. Positive. Again, there is a shortcut if you do not prefer the modeling of it. Remember something called keep the 8, add opposite of -9 is 9. 8 plus 9 is 17. Trial 4. -3.5 plus -3 1/4. Do you predict positive or negative? So if I start at 0, I go to -3.5. -3 1/4. That means I go 3 1/4 to the left. So it's going to be negative. We're not finding an answer yet. We're just practicing positive, negative. The last trial is -3 1/2 plus 4 2/3, positive or negative. So if you start at 0 and you go -3.5, but then we go 4 units to the right, that would be on the positive side. So we're going to be practicing today adding and subtracting negative fractions. So let's start with -310. So here is -310. I'm going to show you two ways you can solve this. It is left of 0 plus 1/2, which goes to the right. So here's -310. It's going to the right. So I predict the answer will be positive. But can I rename 1/2 with a common denominator? I will rename 1/2 as 5/10. So this makes a 0 pair. Bye-bye. What do you have left? 2/10. Next one, -3/8. So -1/8, -2/8, -3/8, plus -1/4. Right here. So it's going to left of it. Can I rename 1/4 with a common denominator? I'm going to rename it as -2/8. So how many 8's do we see here? I see -5/8. So I renamed -1/4 as -2/8. -3 plus -2. Remember the integer rules. A negative plus a negative makes a more negative, -5/8. Next one, 1/3 minus -4, or take away -4. Using what we know about integer subtraction, we know we start with 1/3. We add, what's the opposite of -1/4? 1/4. So we add 1/4. Can we rename 1/3 and 1/4? What do they share in common denominator? I believe they share the 12. So 1/3 can be 412. And 1/4 can be renamed as 312. So this is 412 plus 312 is 712. So let's look at our question. A swimmer is at the depth of -7 2/3 feet. So the swimmer's right here. He's below the sea level. He saw Nemo and he dove another -1 5/6 feet. So he dove another. So he's going down -1 5/6 feet. What is his water depth? So we know the answer will be negative. So he went down further. So -7 2/3 plus -1 5/6. Or you could have said -7 2/3 minus 1 5/6. Remember, add the opposite of positive would be negative. So they both mean the same thing. Now it is time to solve this. What common denominator do these share? Let's rename it. They share 6. -7 multiply the numerator and denominator by 2 be 4 6 plus -1 and 5 6. So what do you do when you have a negative plus a negative? We add them up together. So -7 plus -1 is -8. 4 6 plus 5 6 is 9 6. But, oh, this is improper. So, I'm going to draw this. We have a 6. This is one hole. But then if you draw 7, 8, 9, that's 3 extra. That'll be 1 and 3 6. So it's -8 plus 1 and 3 6. So it'll be -9 and 3 6. Or isn't 3 half of 6? So -9 and 1/2. Again, some of you may look at this and say, I don't know how you came up with that 1 3 6 right here. I am lost. Let's go back again. Can 6 go in 9? One time. 3 is left over. So that's where I got the 1 and 3 6. How many 6s go into 9? One time. 3 left over. 1 and 3 6. Next one. Ronnie noticed that the temperature was 5 1/4 degrees Fahrenheit outside. By mid-afternoon, the temperature dropped 7.5. So positive or negative? Well, here's 0. I predict the answer will be somewhat negative. Dropped. So it means minus. Or, isn't that adding a negative? 5 1/4. Add, because subtracting, remember, add the opposite. Keep the 5 1/4. Add it. What's the opposite of 7.5? -7.5. What was the temperature at mid-afternoon? So what denominator do 5 1/4 and 7 1/2, -7 1/2 share in common? They share the fourths in common. So we have 5 1/4 plus -7. Multiply the numerator and denominator by 2, so it'll be 2/4. So now, this is where it gets a little more harder. So we have 5 whole. 1, 2, 3, 4, 5. And we have 1/4. And then we have -7. 1, 2, 3, 4, 5, 6, 7. And -2/4. I'm going to shade these in because these are negative. What do you remember about 0 pairs? Oh, all right, fine. I'll have to use a different. So you know what? We have to make some 0 pairs. These 5 will make 0 pair with this one. This will make a 0 pair with this one. So what do we have left? We have -2 and 1/4. What was the temperature at mid-afternoon? -2 and 1/4 degrees Fahrenheit. And that is adding and subtraction of positive and negative numbers.